another 10 minutes. 10 minutes. Good morning, students. Good morning. Can you hear me? Please respond.
Good morning, sir. Yeah, we can hear you.
Okay, fine. So just we will wait for another 2 minutes. Please mute your mics. Please mute your mic.
Next hairstyle.
Shivanand. Please, all of you mute your mics. Okay. Okay, shall I start? Shall I start? So we were discussing the FIR filter design. In FIR filter design, what we have understood, why it is considered as the FIR filter, the reason is, first point, whatever the impulse response of that system or impulse response of that filter, we are going to consider it is of finite length. That is the first condition. Next one is I want to achieve the linear phase. To achieve the linear phase, we have come to a conclusion that h of n must be either h of m minus 1 minus n, or it must be h of n must be equal to h of m minus 1, sorry, minus of h of m minus 1 minus n. That means in this case it is considered as the symmetric impulse response, and this is considered as the anti-symmetric impulse response. So when we consider the symmetric and anti-symmetric impulse responses, because of the nature of this, and if we are considering that the h of z is having a real polynomial, sorry, real coefficients, in that scenario my zeros will be, please mute your mic, please mute your mic. I can hear the background noise as well as the disturbance done by you people. Please try to understand. So because of this symmetric and anti-symmetric nature, the zeros of h of z will be existing in the mirror image symmetry. What we mean by mirror image symmetry, that we have seen. And then, excuse, I don't know who is that. Uh, Someone please instruct your friends to mute their mic. This Abhigiri, I think that fellow has not muted his mic. Everyone please mute your mics. Okay. The zeros of h of z are existing in the mirror image symmetry. Then after that, the length, whatever the length we are considering, the length of h of n, that is m. So this m can be odd or even, and similarly h of n can be symmetry or anti-symmetry. Because of these two constraints, we will come across the four different cases. Case 1, that is known as the type 1 FIR filter, where type 1 FIR filter is having m is odd, the length of that h of n will be odd, and h of n will be h of m minus 1 minus n, that is symmetric nature. So dear students, is it not annoying?
ऐसे क्या करना है अभी तो थोड़ा देखना पड़ेगा ठीक है ना और समझिए ना
Class representatives, please instruct your classmates to mute their mics. Okay. Type 1 means m is odd and h of n is symmetric. This sort of type 1 FIR filter is suitable. It is suitable to design any filter. It is suitable to design any filter. It may be low pass filter, or it may be high pass filter, or any sort of filter. Four different filters, whatever we have discussed, this type 1 can be used to design any one of the filter. Case 2. In case 2, we are having, this is also known as the type 2. In type 2 FIR filter, m is even, that is the length of h of n is even, and the impulse response of the filter will be symmetric. So this particular type 2 filter should not be used. It is not suitable. This is not suitable to design high pass filter and band stop filter. We should not design high pass filter and band stop filter using type 2. Next, case 3. In case 3, we are having M is odd and my impulse response of the filter will be antisymmetric. That is h of n is equal to minus of h of m minus 1 minus n. So this is known as the type 3 filter. This type 3 is optimum suited for designing only bandpass filter. It is suitable to design only bandpass filter. Okay, it is suitable to design only bandpass filter. Next, type 4. So type 4 is having case 4, that is type 4, where m is even and my h of n is antisymmetric, minus of h of capital M minus 1 minus n. So what for this type 4 should be used? This type 4, I don't know why these people are not understanding the scenario. Okay, in the previous period we were discussing about the why really I am feeling very annoying here. Please, somebody please tell them, whoever is making noise, it is coming from the background, I can understand, but they can mute their mics or no. Pavitra, can you suggest your classmates?
Yes, sir. I'm calling him.
Who is that fellow?
Sir, even I don't know. I just saw the USN and I'm trying to call now. So I'll. Sir? Sir, done, sir. Everyone's on mute.
Okay. Okay. So fourth one, I'm not telling why it is suitable or for which filter I should not use that. That is left to you people. You just think over it and do it. Okay. Now, why filter 1 is suitable for designing any filter, I will not tell you, but I will consider type 2. Okay. Yesterday I wanted to create, or I wanted to have the generic expression or general expression. Thereby I wanted to show that it is suitable to design, sorry, it is not suitable to design high pass filter and band stop filter. So I think yesterday students felt very difficult. So I will consider one example. Anyway, general expression is given in the notes, and even you can refer the previous year video lectures also. Okay. And it is given in the textbook also. So if you want, I can consider it in the general conditions in the next period. Okay. Just now I will consider type 2 with some example. In type 2, m is even and h of n is equal to h of capital M minus 1 minus n. Let me consider h of n is equal to h of 0, h of 1, h of 2, then h of 3 is equal to h of 2, then h of 4 is
Sir,
equal to, yeah,
for
any doubt?
which type of filter case 4 is used, sir?
That's what I told you. I'm not going to tell, you only tell me, okay? You verify it. Now how I am going to consider the example, based on that one, you consider and you tell me. I have left it intentionally, okay?
Okay. Okay, sir.
Hmm. So h of 4 is equal to h of 1. Please 97, mute your mic. 19 is 97, mute your mic. 19 is 97. Okay. So h of 5 is equal to h of 0. Now can you tell me what is m in this impulse response?
6.
M is equal to 6. Length is equal to 6. And what sort of nature I am having for the impulse response? It is symmetric. Yes or no? Symmetric impulse response. Now, let me go to the next page. So I will consider h of z, where h of z is equal to h of 0 plus h of 1 into z inverse plus h of 2 into z to the power of minus 2 plus h of 3. But what is h of 3? It is nothing but h of 2 only. Yes or no? Is it right? Next I am supposed to consider h of 3 into z to the power of minus 3. But h of 3 is equal to h of 2 only. Similarly, for h of 4, it is nothing but h of 1 into z to the power of minus 4 plus h of 0 into z to the power of minus 5. Please tell me, is it right or wrong? Everyone is able to understand. At least anyone respond.
Yes, sir.
Okay, fine. Then I can have h of omega. What is h of omega? H of 0 plus h of 1 into e to the power of minus j omega plus h of 2 into e to the power of minus j 2 omega plus h of 2 into e to the power of minus j 3 omega plus h of 1 into e to the power of minus j 4 omega plus h of 0 into e to the power of minus j 5 omega. Okay. Now what I will do, in this h of omega, I will take, if you consider the center, can you tell me the center value? Now here the center value will be m minus 1 divided by 2. Okay. So it will be 6 minus 1, 5, 5 divided by 2. So 5 divided by 2 is nothing but 2.5. So it is, I can take e to the power of minus j 2.5 omega as a common. 19 EC 97. Any problem? 19 EC 97. You can mute your mic, or intentionally you want to trouble us. Okay. If I'm taking e to the power of minus j 2.5 omega as a common, then I will be having h of 0 into e to the power of j 2.5 omega plus h of 1 into e to the power of plus 1.5 omega j 1.5 omega plus h of 2 into e to the power of j 0.5 omega plus h of 2, this because of this term. So h of 2 into e to the power of minus j 0.5 omega plus h of 1 into e to the power of minus j 1.5 omega plus h of 0 into e to the power of minus j 2.5 omega. Is it making sense?
Yes, sir.
Okay. So e to the power of minus j 2.5 omega into, see here, this is h of 0 into e to the power of j 2.5 omega, and this is h of 0 into e to the power of minus j 2.5 omega. Can I write it as a 2 cos 2.5 omega? Can I write it as a 2 into h of 0 into cos 2.5 omega? Okay, let me separate them properly. So h of
Yes,
0 into e to the power of j 2.5 omega
Sir,
plus,
sir, how did you decide what to take common?
sorry, what to
How
take?
did you
Center
common, sir?
value. I should take center value. I should choose
Center.
the center value.
Oh,
See
okay,
here.
okay.
So here the maximum value is 5, e to the power of minus j m minus 1 omega. Okay, so I should take m minus 1 divided by 2. I should
Okay,
choose that one. Okay.
okay.
So what's your name? 19 EC 97.
Sir, I was not EC97.
Okay, okay. But please mute your mic after asking the doubt. I appreciate your doubts, but please mute because it disturbs me as well as the other students. Plus h of 1 into e to the power of j 1.5 omega plus e to the power of minus j 1.5 omega plus h of 2 into e to the power of j 0.5 omega plus e to the power of minus j 0.5 omega. So I can write this one as my h of omega is equal to e to the power of minus j 2.5 omega into 2 times h of 0 into cos 5 divided by 2, 5 by 2 into 5. Sorry, I'm sorry, omega. Okay, 2.5 omega, so it is 5 by 2 omega. Next, plus 2 times h of 1 into cos 3 omega by 2 plus 2 times h of 2 into cos omega by 2. Is it right?
Yes, sir.
In general what it happens, I'll just give it later onwards. Now I want only magnitude. I'm not worried about the phasor response. So if you consider the magnitude, it will be 2 times h of 0 into cos 5 omega by 2 plus 2 times h of 1 into cos 3 omega divided by 2 plus 2 times h of 2 to cos omega by 2. Okay.
Okay.
19 EC 97. Okay. So then what I can write, let me consider h of omega, the magnitude of h of omega at omega is equal to 0. What it will be? Can anyone find? H of omega at omega is equal to 0.
2 times h of 0 plus h of 1 plus h of 2.
Is it right?
Yes, sir.
Now It may be 1, it may be 0.5, it may be 0. It all depends on these things. Yes or no? Now I cannot say what will be the magnitude at omega is equal to 0. Do you write?
Yes, sir.
Next, let me consider h of omega at omega is equal to pi. Can you tell me the value at omega is equal to pi?
Minus 2h of 0, minus 2h of 1, minus 2h of 2.
No, pi.
No, sir, it will be 0. Sorry.
It is 0. Understanding? It is 0. So that means what? If you note down the frequency response in type 2, if I consider this one is a omega, and here I will consider the magnitude of h of omega. So at omega is equal to 0, at omega is equal to 0, I cannot say what it will be, but so at omega is equal to pi, my magnitude will be 0. Okay. Now if you consider the ideal characteristics of the high pass filter, suppose if I consider the ideal high pass filter, how it will be, or even band stop filters, at omega is equal to pi. At omega is equal to pi, what is the magnitude expected in the high pass filter? What is the magnitude expected at omega is equal to pi in ideal high pass filter?
It should be 1.
It should be 1, isn't it? It should be 1. But in this scenario, are we getting 1 here? Are we getting 1 here at omega is equal to pi? I don't know about this region. I don't know what is going to happen at omega is equal to 0. But in this scenario, at omega is equal to pi, I am getting 0. So that means actually high pass filter is expecting 1 magnitude at omega is equal to pi, but that we cannot achieve. Yes or no? Please tell me all of you are able to understand.
Yes, sir.
So that's why this type 2 cannot be used to design the high pass filter, even band stop filter. Even for the band stop filter also, how will be the ideal band stop filter? It is like this. At omega is equal to pi, I must have the gain of 1. But here the gain 1 is not introduced. It is introducing 0 gain at omega is equal to pi. So that's why this type 2 filter is not suitable for the designing high pass filter and band stop filter. Understanding?
Sir, can you repeat once, sir? I'll note it down.
Who has asked the doubt for
Sir, Vishnu.
repetition? Huh?
Vishnu.
Vishnu, I'll explain. Okay, but I need a one favor from you people. I want to identify that fellow 19 EC 97. Who is that? I think 95 96 they will be knowing who is 97. Okay, I want to talk to him personally and to his family members also. I don't know why they are keeping intentionally. That fellow has kept mic on and he has went out. If anybody of his friend is there, please inform him. Okay, Vishnu, I'll explain. Listen here. See here. Are you listening, Vishnu?
Yes, sir.
At omega is equal to 0, I will be getting this magnitude of h of omega as 2 times h of 0, 2 times h of 1, and 2 times h of 2. Now, what will be that magnitude? That I don't know. It all depends on my h of 0, h of 1 and h of 2. That means it depends on the impulse response values. Okay, but if you consider the magnitude response at omega is equal to pi, what is going to happen from this expression? From this expression, I can write 2 times h of 0 into pi divided by 2 plus 2 times h of 1 into cos 3 pi by 2 plus 2 times h of 2 into cos pi by 2. So all are becoming the cosine terms. The cosine terms will have the odd integer multiple of the pi by 2. Odd integer multiple of the pi by 2. You take any m value. It should be even and h of n should be symmetric. In you take any 100, you may choose m is equal to, sorry, not 100. It should be a even number. Yeah, it should be even number. So you choose m is equal to 100 or m is equal to 1000. You write this expression, general expression or whatever the expression, you will get at omega is equal to pi, you are getting the magnitude response as a 0, because all these cosine terms will be having the odd integer multiple of the pi by 2 at omega is equal to pi. So therefore you will be getting the magnitude response at omega is equal to pi as a 0. Now I know that in type 2 filter at omega is equal to pi, I am getting response is equal to 0. But high pass filter, what is ideal high pass filter? What it is expecting? It is expecting the magnitude of that h of omega must be equal to 1 at this pi. Understanding?
Yes, sir.
Similarly, even band stop filter is also expected to have the magnitude response of 1 at omega is equal to pi. But that is not happening in this skin scenario. Understanding? That's not happening in the type 2 filter. So
Yes,
that's
sir.
why type 2 is not suitable to design the high pass filter and band stop filter. Making sense?
Okay.
Okay. Anybody else is having any sort of doubt? Shall I proceed?
Yes, sir.
Okay. Next, after this, I'm considering type 3. Okay. In type 3, what is the m value?
M is odd,
M is odd. And what about the h of n?
antisymmetric.
It is antisymmetric. So h of n should be equal to minus of h of m minus 1 minus n. Okay, I will not go for the general conditions. I will choose one example. I'll choose m is equal to 5, simpler one. Okay, even I can choose m is equal to 3 also. You may feel it is a very trivial, so I will choose m is equal to 5 and I'll consider h of n something like this. So h of 0, h of 1, h of 2, then h of 3, but that h of 3 is equal to minus of h of 1, comma, h of 4, that is equal to minus of h of 0. I hope it is of length m is equal to 5. Do you agree? Yes or no?
Yes, sir.
Yes, sir.
What about this value?
Middle value, 0.
It must be 0. Okay, it must be 0. So then what I am getting for h of z, I'll be getting h of z is equal to h of 0 plus h of 1 into z to the power of minus 1 plus, not plus, minus h of 1 into z to the power of minus 3 minus h of 0 into z to the power of minus 4. I hope nobody is having any issues here. Clear? Right? So if I consider h of omega, it will be h of 0 plus h of 1 into e to the power of minus j omega minus h of 1 into e to the power of minus j 3 omega minus h of 0 into e to the power of minus j 4 omega. Now here I will choose the m minus 1 divided by 2 as the center value. So m minus 1 divided by 2 is, m is 5. So m minus 1, 4. 4 divided by 2. So it is 2 e to the power of minus j 2 omega. I will consider it as a common. Then I will be having h of 0 into e to the power of j 2 omega plus h of 1 into e to the power of plus j omega minus h of 1 into e to the power of minus j omega minus h of 0 into e to the power of minus j 2 omega. Please tell me, is it right or wrong? Is it right?
Right, sir.
Yes.
Then I can write this one as e to the power of minus j 2 omega 2j times h of 0 into sine 2 omega plus 2j times h of 1 into sine omega. Making sense?
Yes, sir.
So I can take this j outside. So e to the power of minus j 2 omega. This j is common in all the terms, so I can take it outside. If I'm taking it outside, can I write it as a e to the power of j pi by 2? J can be written as e to the power of j pi by 2.
Yes, sir.
Why? It is cos pi by 2 plus j sin pi by 2. So it is cos pi by 2 is 0 plus j into sin pi by 2. That is sin pi by 2 is 1. So it is just a j. Okay. So this will be 2 times h of 0 into sin 2 omega plus 2 times h of 1 into sin omega. Okay. After this, what I can write, I want only the magnitude. The magnitude of h of omega, that is equal to 2 times h of 0 into sine 2 omega plus 2 times h of 1 into sine omega. Now, can I find out the magnitude response at omega is equal to 0? What it will be?
0.
0. Yes. Then what about the magnitude response at omega is equal to pi? What is magnitude response at omega is equal to pi?
In 0.
Once again, it is 0. That means what? The type 3 filter, will have here at omega is equal to 0 also it is having magnitude response 0, and at omega is equal to pi also it is having 0. Okay. If you consider low pass filter, what is there? We expect magnitude of 1 at pi is equal to omega is equal to 0, isn't it? So low pass filter cannot be designed. High pass filter should have the magnitude gain of 1 at omega is equal to pi. So this is not allowing to design high pass filter, even band stop filter. So what we can design? Just we can design a filter structure, something, or frequency response of the filter, something like this. So this is nothing but the frequency response of the band pass filter. That's why type 3 is best suited or optimally suited to design only band pass filter. It cannot be used to design any other filter. Okay, understanding?
Yes.
Okay, so here I have chosen some finite, means I have chosen only m is equal to 6 and m is equal to 5. Thereby I have come to a conclusion that which filter should not be used to design which particular sort of filters. Okay, so type 4 I am leaving it to the students only. You please work out and find out, tell me where, for what filter it may be suitable, or for what filter it may not be suitable. You think and tell me. Okay, even you can refer textbook. I'm just leaving it as an one assignment, small assignment. Okay, next coming to the design of
Sir, 1 second, sir.
uh,
I'm writing, sir. 1 second.
right, right.
So type 4 is only for high pass filter.
I have to check. Honestly speaking, I have not checked. Okay, with the next period I can tell you. Today evening I will sit and do it, and I'll tell you.
Sir,
Hmm.
type in type 2 h of omega at 0 is not 0, no sir.
In which filter you are talking about?
In type 2,
In type 2, let me go to the previous slide. Ah,
h of omega is not 0 at 0.
yeah.
So how is it applicable to BPF?
uh, I can make this summation so that it can be made 0. What I will choose? I will choose h of 1 and h of 2 as a minus 0.5, minus 0.5, and h of 0 I will choose it as a 1. Can I do like that? Just I'm giving you one empirical example. I can choose h of 1 as a minus 0.5 or minus 0.75. You can say h of 1 is equal to minus 0.75 and h of 2 is equal to minus 0.25, and h of 0 I'll choose it as a 1. Then it will become 0 at even at omega is equal to 0.
Yes, sir.
Then it can behave like a band pass filter. It may.
Okay, sir, understood.
Okay. Now let me go to the design of linear phase FIR filters using Windows. How we are going to design a linear phase FIR filters using Windows? See here, we will be having a desired frequency response. Assume that I want to design a low pass filter. Okay. Just consider that I want to design a simple low pass filter whose frequency response is something like this. This is my desired filter frequency response. This is minus WC, this is plus WC 0, and this is pi, and here is minus pi. And this magnitude response I'm going to consider 1. Okay. So I know what sort of filter I want. Now this omega c may be by pi by 2 or pi by 4. You just assume, just I'm considering one example. Assume that this omega c is equal to pi by 4. So then this will be minus pi by 4. Okay. So now I know the desired filter frequency response. Now I can find out the HD of n. What is this HD of n?
Inverse Fourier transform.
Yeah, inverse Fourier transform, discrete time Fourier transform. So how to obtain that? I'll apply the definition for that inverse DTFT formula. So HD of n, the desired frequency, sorry, the desired filter impulse response is nothing but 1 by 2 pi integral from minus pi to pi HD of omega into e to the power of j omega n integrated with respect to omega. Can anyone find, can you tell me that what it will be?
Sync.
Sync function. Okay. It will be sync function. So I can write this one with respect to this example. Just I will consider with respect to this example only. So my HD of n is equal to 1 by 2 pi integral of HD omega. HD omega is 1. Okay, it's magnitude response. I want ideal filter. Of course, practically we cannot design ideal filter. So 1 is multiplied with the e to the power of j omega n integrated with respect to omega between minus pi by 4 to pi by 4. Okay. So this will be 1 by 2 pi. So it is e to the power of j omega n divided by j n between the limits minus pi by 4 to the pi by 4. So it is 1 by 2 pi. I can write this one as 2 sine pi by 4 n divided by n. So now if you find out this, mm, this 2 get cancelled. This is pi n. So it is 4 times sine pi by 4 n divided by pi by 4 into n. Is it 4 or 1 by 4?
1 by 4.
Okay. So I can write this one as 1 by 4 sin. Okay, let me consider sine pi by 4 n divided by pi by 4 n only. Okay, let it be as it is. So can you find out with the different n values? Can you find out the what will be HD of n? You can just you can consider different n values. Okay, so n is equal to minus 10 to 10 or whatever values. So at n is equal to 0, it will be 1 by 4. One by 4 at n is equal to 0. At n is equal to 1,
Sir, at n equal to 0, it won't be defined, no, sir.
Huh?
Sir, at n
Apply.
equal to 0. Okay, limit.
Apply. Yeah.
Okay.
Apply L hospitals rule. Now tell me at n is equal to 1 and minus 1.
Sir, at 1 and minus 1, 0.225.
0.225.
225.
At n is equal to 2, it will be still lesser than 0.225, but still it will be greater than 0. At n is equal to 4, it will become 0. Sin pi divided by pi. So sin pi is 0. So at n is equal to 4, it has to become 0. Similarly, at n is equal to 8, it will become 0. Is it right?
Yes, sir.
It will be something like this. Now you are having HD of n like this. Can you, now it is going up to where? For what values of n that HD of n will be existing?
Infinity.
It will be existing from minus infinity to infinity. So then is it possible for me to consider all infinite impulse samples, impulse response samples?
No. No,
Then
sir.
what I am supposed to do?
So multiply it with a finite number of train of impulses.
Finite number of train of impulses. Can you, Vishnu, can you tell me properly what you mean by that?
Sir, if you multiply it with a signal having finite length, you
Ah,
can cut down even HD of n, sir.
okay.
So just so that you don't alter magnitude, you multiply with unit impulse.
Okay. See here, instead of choosing infinite length, can I choose a particular range? Just it is something like a multiplying with the rectangular window. I will choose, let me say, instead of taking from minus infinity to plus infinity, I will choose it from the minus 10 to 10. I will choose HD of n only for n between minus 10 to 10. Just I'm giving one example. That means what? I will use one rectangular window. This rectangular window is something like this. I will multiply with this. It is not in continuous. It is in the discrete time domain. I will choose pick up only this. How I can do that? This can be achieved by multiplying the HD of n with a particular window. Okay. Now I will get h of n, where h of n is hd of n into w of n, where w of n is the window. Okay, w of n is the window, where that window can be it is of different nature. Okay, now I will not come 19 EC 97.
Sir,
Ah,
I think you only can mute him, sir.
I don't know how to.
Zoom meeting, the participants go there. I think you can mute from there.
Okay, I'll check. But I will not leave that fellow. Okay, I'm not getting that option. I don't know how to mute others. Okay, so now I will be choosing a particular set of values. Let me say from I will choose a finite m length impulse response. Okay, m length impulse response, but that can be achieved using the windows. But before going to the windows, I would like to tell you another important point. Okay, now n is varying from minus infinity to infinity. Out of that, I will be choosing only finite set of the hd of n. That I can do. But before choosing that, I have another practical problem. Can anyone note, can anyone identify what is that practical problem?
So because we are not taking the whole sequence, there'll be a change in the frequency domain.
Obviously it will be. Yes, you are right. Definitely we cannot achieve the required or desired frequency response. It will be slightly deviated. Okay, it will be slightly deviated. So to achieve the desired frequency response, we have to keep on increasing the m number of samples. This whatever the capital M I am choosing, we have to keep on increasing so that it becomes, it may be very close to the desired one. Okay, obviously we will not get the desired one. But another problem is there, another important problem is there. This is somehow it can be resolved by increasing the m. I can reduce that problem. Okay, idealness or whatever the desired frequency response is there, that can be achieved by increasing m. But there is another problem. You look at the hd of n. Look at the hd of n.
Sir, you can't store HD of n, sir.
No, that's not the problem. That's not the problem. We can store finite number of m samples, you know, because it is a discrete in nature. hd of n is discrete, and we are choosing some finite m values only. Look at the hd of n. Look at the hd of n. I am circling something.
Sir, anti-causal.
Yes, very good. See here, my hd of n is anti-causal also. It is having some non-zero magnitude of hd of n for n negative values. That means it is not practically realizable. I cannot realize such filter which is anti-causal. Yes or no? Is it making sense? Now what I can do, now this side, this is negative portion. In the negative portion indicates that it is an anti-causal system. So what I will do here, if I am choosing m is odd, let me say type 1 only. That's why we are considering only type 1 filters. When where m is odd, then what is going to happen? We are choosing one sample at n is equal to 0 and m minus 1 divided by 2 number of samples right side. Suppose if I choose m is equal to 9, then the one sample will be chosen at n is equal to 0, 4 samples will be chosen right side, and 4 samples must be chosen on the left side. Then what I can do, can I shift it towards the right side? This whatever the 4 samples are there on the left side, can I shift it towards the right side? Instead of having hd of n, can I consider hd of n minus m minus 1 divided by 2? Making sense? Please tell me. You are able to
Yes, sir.
understand? Instead of considering hd of n, I can consider HD of n minus m minus 1 divided by 2 like this. Then what will be the implication in frequency domain? What happens in the frequency domain? My HD of omega is nothing but it will not be just 1 between for omega between minus pi by 4 to pi by 4 and 0 otherwise. It will not be like this. What is going to happen? My HD of omega now, it will become modified. What
E
it will
power.
become?
E
So
power.
it is not just a 1, it is e to the power of minus j m minus 1 divided by 2 into omega. Understanding? It will introduce linear phase. Understanding? So in time domain, if I am shifting it by m minus 1 by 2 number of samples, in frequency domain, it is introducing a phasor angle. So now my HD of omega will be no more just a magnet, just a 1. It is e to the power of minus j m minus 1 divided by 2 into omega, between omega is equal to minus pi by 4 to pi by 4 and 0 otherwise. Understanding? Making sense?
Yes, sir.
Please tell me, all of you are able to understand?
Yes,
Sir,
sir.
magnitude will remain 1, no, sir?
Yeah, magnitude will be remaining 1. Ideally, what we have chosen, just we have considered 1 only here. I have not introduced phasor angle also. But where we end up? We ended up at the anti-causal system. To make it causal, we are supposed to introduce the phasor angle.
Okay.
That's why, if you remember the yesterday's class, once I have told you why we are supposed to consider the linear phase. If you don't consider the linear phase, it is difficult to design the filters. Okay.
Yes, sir.
Okay. At this point, I'll stop. In the next period, I will continue with the windows. So now we have understood why shifting of the impulse response is required, and the implication of the shifting in time domain results in the phasor delay in the frequency domain, or phase in the frequency domain. Okay, at this point I'll stop.